Hello everyone, my name is Aaryan and we are here to discuss the Leetcode Weekly contest 443 which took place today. So I got global rank under 75, precisely it's 73, and it may got updated further, but yes, I solved all the four problems during the contest. So we will be discussing the approach of all the four problems and how I approached our mind, the intuitions behind them. So let's quickly start with the very first problem. So it says that you are given a integer array cost of size n, and you are currently at position n, and at the which is at the end of the line, and in a line of n plus 1 people. You wish to move forward in the line, but each person is in front of you charges a specific amount to swap places. The cost to swap place with person I is given by cost I, and you are allowed to swap places with people as follows. If they are in front of you, you must pay them cost I to swap with them. If they are behind you, then you can swap with you for free. So return in an answer of size n, where answer of I is the minimum total cost to reach at each position I in the line. So let's see the first example, which is 534132. So this is question A, which has a array 5 4 sorry 534132 53413 and 2. Correct. So currently we are standing at this position and we want to move to all the positions, and we have to construct a array answer of I, which tells how much cost do I need to reach at any certain point in the queue. Cool. So to move from this point to this point, if there are two options. First option is you swap with any person and you pay the cost of I, which is if I move from last position to this index, which is actually 0 1 2 3 4 or 5. So to move to fifth index, either I would pay 2 to the person and move to this point. So my first option is to pay 2 to this person. Second option is I can go to any of these places, and what I can do, let's suppose I move to position 3 by paying the cost 3. So from this point I can move back in the row or in the queue, which doesn't cost me anything. So after moving to the point first index, I can freely move back and reach 5, which will cost me 3. But that's not a good idea because that cost is already greater than the cost that I can actually pay to the person to swap the position. So but how can we achieve the minimum cost? That can be easily seen that either I'll pay the cost of I and get that position. Otherwise, what I'll do is search for any minimum value before my current index in the cost of I array, and I'll go to that point by swapping the position, which will be 1 in this case. So I'll move to the position 1 by paying 1 as the cost, and from that one position I can easily move back and reach 2. So my second option would be 1, and which is definitely less rather than 2, so my answer would be 1. Similarly, for reaching at this position 4, what I can do is either I would pay 3 or I would pay 1 and then move back to this position, which would be more convenient for me. Similarly, for this position, both of the options are same. For this particular position 4, there are two options. Either I'll pay 4 or I'll search for any lower value in this section, which is 3. So 3 is lesser than 4, so I can definitely go by paying 3. Similarly, for this index, I can easily swap by paying 3. But for this point, there is no any option left for going to that point and then coming back. So we have to pay 5. So that would be my answer, which is 533111. So 533111 is the answer for this test case. So by doing a dry run on this test case, we are easily able to get the idea that what we can do is start. If this is my array, I need to know for any index which is the minimum value before index, which is in this range. Cool. So what I can easily do is start iterating on the array. We'll take the count of the minimum value encountered so far. So if I know the minimum value before this index, so I can easily get the minimum cost to reach this particular index and fill my answer of I as the minimum value. So the total time complexity required to do this would be order of n, and the total space complexity will also be order of n to construct the answer of the answer array. Cool. Let's see this in the code. It's pretty straightforward. Yes. So here we have taken the size of the array, constructed the answer, then took the initialize the minimum as the maximum value of integer, then started iterating on the array. For every index we are taking the minimum of cost of I, and then we are updating my answer of I. Why are we taking the minimum before updating answer of I? Because up till here, if I have all the minimums present before this, though the another option could be swapping with this person also. So first I'll take minimum of this, and then I'll move forward by updating my answer of I. So this was the code for this problem. I hope you understood it, and let's move to the next problem. Let's start with the problem number 2, which is longest palindrome after substring concatenation 1 and 2. So as I'd always said earlier also, that whenever you encounter two problems with the same problem statement and just difference in the constraints, always aim for the harder problem, because there you just have to solve some a better version of the problem with more optimizations, and you will be able to solve two problems in the same time as compared to solving first problem with brute force and then thinking of the optimized version. So let's discuss the problem third, and the same code can be used to solve problem 2. So the problem says that you are given two strings s and t, and you can create a new string by selecting a substring from s that can be possibly empty, and a substring from t also that can also be empty or can contain some characters. Then concatenate them in order and return the length of the longest palindromic substring string that can be found this way. So for this, let's take the look at the constraints. So the constraints are up to 1000 for the length of s and t. Similarly, the constraints in problem B are up to 30 only. So in problem B, you can go with some brute force by generating all substrings and then checking whether that they are palindromic or not. And if they are palindromic, you can take the maximum of lengths of all possible palindromic substrings. So let's discuss the third problem, and that same can be used to solve the second problem. So question 2 is same as third, or you can use brute force also, as constraints are very low. So n to the power 3, 4 or n to the power 5 solutions can also be accepted. But let's discuss the real question, which is question number 3. So in this question, let's see it with the help of example. S is A, B, C, D, E. We have a string S, which is A, B, C, D, and E. Similarly, a string T, which is E, C, D, B, A, E, C, D, B, and A. And we have to return the length of the longest substring, that is palindrome, and generated by taking substrings from S and T and concatenating them. So from S we can see that we can take ABC, and from T we can take BA. So combining them, this is ABC plus BA. From here we will have a string A B C BA, and we can see this is a palindrome. Why a palindrome? Because the first and last characters are same, the second and second last are same, the third and third last are same. So from reading from front and back, all the characters match, so we can say that yes, it is palindrome, and the length of this is 5. So the answer for this test case would be 5, as we cannot make any string greater than the length of this. Cool. So just after looking at this test case, you can generate as many possible ideas or cases that how can we make substrings from, or palindromic substrings from S and T. So if we think of case 1 is empty from S, so in this case we can say that yes, our answer would be max palindromic length substring in T. Yes, let's take example of this test case. So if you have, let's say, Z C B A as S, and you have T as D E F G H G F E and D. Cool. So in this case you can see that even after taking any character or any substring from S, we won't be able to concatenate it with T and get a palindromic substring. So what we'll do, we'll take empty substring from here, and we can see that yes, this whole string is palindromic. So max length is 1 2 3 4 5 6 7 8 and 9. So my answer would be 9 in this case. Cool. This is our case 1. Similarly, the case 2 will be the vice versa of this, which will be empty from T. So my answer would be max palindromic length substring in S. Cool. So these are the two cases. Let's see the third case, which will be a generic case, that yes, some part of S plus some part of T, and we can concatenate them to get a palindromic substring. So let's suppose you have S as A B C D, and similarly you have T as E C D A. We can clearly see that yes, the first part of this is equal to this, but how can we say that yes, they are matching, or how can we easily check whether some part of S is matching with some part of T in terms of palindrome? So the better thing is you just reverse T. If we reverse T, my T would look like A B C E. Now instead of finding the reverse of or the palindromic mirror of ABC, we just have to find the same in T. That would be more easier for us. So reversing that T will help us to find the same substring in T. This is just an observation. After that, the case that we had just seen in the example, which is this ABC and EC DBA, if we just take extended version of this. It would be, let's say, A B C D C Z N. Cool. Similarly, T is Q R B A. Cool. If we see, what are we gonna do? We are gonna reverse T, so it will look like A B R Q. Now if we try to find the matching string in S and T, it will be AB AB. Cool. So we can say that yes, we can generate a substring or a string result from some part of A, which is AB, and some part of T, which is BA and AB in this reverse order. And we can make a substring, or we can make a new string ABBA, which is palindromic, and its length is 4. But this may give us wrong answer. Why? Because the final answer should look like this, which is A B C D C and B A. How can I say this? Instead of taking just AB, we can take A B C D C. This is A B C D C from S. This is B A from T. If we combine them, yes, the final answer would be 1, 2, 3, 4, 5, 6, and 7. So obviously 7 is greater than 4, and this should be our answer. But up till here we are only considering the matching part in both of the strings. But how can we check whether some extra part can be accommodated? This is, can we take any extra part? The answer is no. We cannot take any extra part. If this is C D E, we cannot take the whole C D E, because this is not a palindromic substring. But instead of this C D E, we can still take C. Why? Because in AB and BA, in between this, I can only put, okay, let's write it down here, that we have some part of A. Cool. Here we have some part of T. This is not A, this is S. Matching with S part. Both of these parts are matching, which is ABC and ABC in this case. So what we can put in between is, if there is this ABC, sorry, this AB, here is this BA, what can we put in between? Either empty string, that will make ABBA, either one character, or let's generalize this more properly, or we can put a palindromic substring starting at I plus 1. What is this I plus 1? So some part of S which is ending at I. What does I mean with this ending at I? So our string is A B C D C and Z N. Cool. So here my matching part was ending at this I, and there is a palindromic substring starting at I plus 1, which is this, and the length of this is 3. So I can easily put these 3 characters in between, and we can still get the resultant string as a palindrome. Similarly, there can be no palindromic substrings matching further. So in that case, we can still put C, because a single character is also a palindrome in itself. So we can still put C, and if we put C, my length would be increased by 1. So in both of the cases, my length is gonna increase from just instead of just taking the matching part from both S and T. And for this case, there can be the reverse of it. So instead of S, we can also take some part from extra part from T also, which is, let's say, AB Zn from here, and T as CBC or CDC B. Cool. So from this BA, from this AB, we can get a string. But in the middle, what we can do, what we can put this part, because this is palindrome, and we can put this extra part from T to make a string which is also palindromic. So instead of putting any palindromic string, if we put any generic string, then that would breach the palindromic property of the total string that we are forming. But if we put some palindromic string, we know this part is palindrome with this, and if the middle part is also a palindrome, so in that case that would help in putting extra length into the final string. So here we had found a string of length 7. Cool. So total there are two possibilities, that are, we are gonna take some part of S ending at I, plus we will put something in middle. Here is some part of T. Let's say we are discussing everything in terms of T with S. So some part of T starting at J equal to part of S. What I mean to say is, if there is AB here, so we should be considering BA here. Cool. So what we'll put in between, first option is palindromic string ending, or sorry, we can say starting at I plus 1, which was the case of S that we just discussed here, that some part of palindromic string is starting from I plus 1, and whatever is the length of that, we can take that into our account. Second thing is palindromic string ending at J minus 1. Why J minus 1? It means that this palindromic part is present in T, and if my matching part is from this index J, so whatever is the maximum length of palindromic string up till here, I can also take that into my account. Cool. So these are the two cases that can help me increase my length. So how can we get to this answer? First thing is, we can use dynamic programming. How dynamic programming? Because to compare both of the strings, we are gonna encounter some part of overlapping subproblems. How? So if there is a string S, which is A, B, C, D, there is a string T, which is Z, A, B, C. So there can be a possibility that starting from this index and from this index, they can start matching, and my answer would be in starting from both of the indexes. Second option is, I'm not gonna take this, I'm gonna start from this index. Yes, it can be a possibility. Another is, instead of this, I'm gonna start from here and from here itself. So there can be different subproblems that will be overlapping each other, and we have to get the maximum answer from all of those subproblems. So yes, we can go into dynamic programming, and as we had discussed, we will be using a reverse version of T, which will help us compare S and T easy. Cool. So for a state like dp, we can maintain a state which says dp of ij is the max, uh, or instead of max we can say longest continuous substring ending at I in S and J in T, which are matching. What does this mean? So if my string S is this, which is this A, B, C, D, and initially my T was D, C, Z, Z, but after doing this, I will reverse this and it will be Z, Z, C, D. So what I'll do is I'll keep a track of my I, I'll keep a track of my J, and my dp of ij will store the longest continuous substring ending at I. Ending at I means this, and j here, which are matching, which will be C and C for both of them. So the dp of ij in this case will store 1. Cool. So this is, if this is my state, so what can be the transition of this? So if at any point my s of I is equal to s of j, in that case I know I have found a updated length. So my dp of I and dp of j would be nothing but dp of I minus 1 j minus 1 plus 1. So I'll go back and look into the smaller sub problems, that what was the previously computed maximum length from these 2 points, and we'll update them by plus 1 as we had found a matching character. Else if they do not match, I know my dp of ij is nothing but 0, because I have to start finding a new string from this point onwards. Cool. So at any point I know, if I am running over a string s, at any point I know what is the max length matched up till this point in s, similarly which is matched with t. Cool. So I know if at any point this much length is matched. So what are these? These are the part A and part B. We know the length of this is same, so we can easily say that yes, 2 into dp ij is the length of my answer. This is a possible length. This was the first option. Second option was to take some palindromic part of s or some palindromic part of t. So let's see how are we gonna do that part also. So for that, if we see that for this particular dp solution, our time complexity is going to be order of n square, or precisely it will be n into m. So if we see the constraints, which are 1000 already, so the time complexity for this will already be 10 to the power 4. Cool. So second thing is, if we start iterating from the next index I plus 1 in s, and we'll look for the palindromic part in it, it will gonna cost us more time and will add more time into it. Similarly, that more time will be added for checking the part of t also. So the time complexity will increase, and that is not going to fit into our constraints. Oh, this will be 10 to the power 6, not 4000. Cool. So in anyhow, it will be either n or m for string s or t. So that will gonna cost us 10 to the power 9 time complexity, and this will not fit into our constraints. So we have to pre-compute something that will help us get the calculation of this thing that we are looking for. That is palindromic string starting at I plus 1 and palindromic string ending at j minus 1. So as we had reversed the string t, so first thing what we need, uh, max palindromic length of string starting at index I in S. Cool. Similarly, second thing is we earlier want something which is the prefix palindromic part of T, which was this. But in our case, we had reversed the T, which is equivalent to A, B, C, D, C. So instead of finding prefix palindromic part from before j minus 1, we can easily say that yes, if I am standing at jth index, I want max length of palindromic part from j plus 1 onwards, which is pretty much same in the case of t like the s. So we need the same thing, that max palindromic length of string starting at index j in t. Why j in t? Because we had reversed t. Cool. So if we have a string this, which is a b c d g h i I h g, so how can we compute this thing in the minimal time? Cool. So what we can do is we can fill last of s array. Okay, let's write it here only with s. So we can compute last of s of I, which will give us this thing, and this is basically first of t of I, which tells the max length of any palindromic string in t. So there can be, if I am talking about this particular index, the palindromic string could lie anywhere from starting from this index to this. I don't know how many characters can come into my palindromic consideration. So I have to check for every other character. And so what we'll do, we'll run a loop for every index, and from that index we'll iterate up till the end again. So there will be a loop, which is the outside loop, you can say, on the number of characters. Then we'll loop again on the inner characters starting from I up till n. And if this is my I, this will be my j, iterating all over, and we'll check whether this substring between I and j is palindromic or not. So if this is palindromic, my length is j minus I plus 1, which we can store at last of s or at first of t of I. Cool. So how can we check whether this substring between I and j is palindromic or not? We can make a recursive function and we can memorize it to store whether some part of this subproblem is already calculated or not. So at any point, if my s of I is equal to s of j, which is my j will be at this point when I will be checking, or let's write the string here again. So if this is my string, which is a b c b a, and I have to check the substring this string as palindromic or not between I and j, what I'll do, I'll compare both of the characters. If they are matching, I know my answer would be between this I minus 1, sorry, I plus 1 and j minus 1. So if they are equal, my answer lies in I plus f of I plus 1 and j minus 1. Else, if they are not same, my answer is no or 0 in my case, because I will be checking whether they are palindrome or not. So we will be maintaining a state of 0 and 1. So this is the recursive case, or at any point the base case would be that my I becomes greater than or is equal to j. We can say that yes, it is palindromic because a single character is palindromic in nature. So that's how I can compute, and we can memorize it so that the check would be order of just a second, I need to erase this. So this function will work in order of 1. Why order of 1? Because for every character we are just gonna check this thing, and the rest of the thing will be used from the memoirs array, and this whole computation will cost us order of n square time complexity, which is acceptable. Cool. So by doing this order of n square iteration, we will calculate first of t for every index I. Similarly, we have last of s for every index I, which tells max length of palindrome, max palindrome length after I. This is max palindrome length after I in t. And similarly, we also have dp of I comma j as max length match in s and t before I and j. Cool. So once this thing is done, we know our answer can be three things. This is the max length match, which will be if a and b is matched, the length would be 2, but the length of the palindrome will be twice of this. So twice of dpij is one answer. Second option is twice of dpij plus the palindromic length after I, which we can use. So last of I plus 1. Why I plus 1? Because here we had discussed that palindromic string starting at I plus 1, that is the maximum length that we need. So that could be the case. Second or the third option is twice of dpij plus first of I plus 1, which will be nothing but the starting part of t, which matches as a palindrome, and we can put in between. So these are the three options that we can check at any point of ij, and we can update our global answer with this. So the total time complexity used for this will be order of n square. This is for s pre-computation. plus order of m square. This is for t's pre-computation plus order of n into m. This is for dp updates plus answer update. Cool. So these are the time complexities for this, and that was the idea or the main approach behind solving this problem. Let's see the code for this also. And if we see the code for this problem, so this was the code for this. We had taken n and m as the size of both of the strings, initialized a dp array. So I will be using the same dp array for memoizing that checking palindromic function also, and the same dp array for calculation also. So I will be updating that array or initializing that array again and again. So then this was my global answer, and you can even start it with 1 because, or let's take 0 because there can be a possibility that both the strings are empty. So reverse t initially so that we can check both the strings in the same direction. And first we need to calculate last of s. So I had made a function get calculated which will return us a string, or sorry, which will return us a vector which of size that we will pass into the function, and according to the string that will pass. So that because at last we have to find the same thing for both the strings s and t. So instead of writing a repetitive code, I wrote this function that initialized the array with that size. This was my loop that we were discussing here. Where it went here, that we'll iterate on every index, and for every index we'll start iterating again up till last to check whether the string between this I and j character is palindromic or not. So this is the function call to check whether it is palindromic or not. So if my I is less than they, then I have to check, otherwise it is palindromic. In this was the base case that we discussed. So at any point, if my answer is not calculated, I'm gonna calculate it, otherwise I'll just return. If it's not calculated, we'll check if s of I is equal to s of j, then my dp of ij depends on the smaller answer, and if it's not same, my answer is that the string between I and j is not palindromic. So this was the function, and for every substring between I and j, we'll check whether it is a palindromic or not. If it's palindromic, then we'll get the length, which is j minus I plus 1, and we'll update my result, which will be the last of s in this case and the first of t in the second case. And simultaneously we'll be updating our answer, so that if there is any condition like this, then that some empty part of s is to be considered, then this will help us compute the max palindromic length from s and t both. Once we have this thing, we'll initialize our dp array again. We'll start iterating from I0 and from J0 up till N and M respectively. At any point, if my both of the characters are different, then we knew that our dp of ij should be 0. So it was already initialized with 0, so we don't have to do that again. So other than that, if the -1 states are not in my scope, we'll just put simply 1 here. Otherwise, we'll get the answer from smaller states and we'll put +1 over there, which is the transition that we discussed. Update I and j will be updating my answer, which is option 1, twice of dpij, which we just discussed here, twice of dpij, and will update my answer. If I is less than 1, less than n-1, which means I plus 1 will be in my scope, so it will be t plus last of s, and similarly t plus first of t from I plus 1 and j plus 1 indexes respectively. So this was the code for this problem, I hope you understood it. And these were the time and space complexity. So the space complexity of my code will be order of n cross m, because this much space I had taken at any given point of time. Instead of making three different or arrays, I had just used a same vector to initialize at different point, and this was the solution for this problem. I hope you understood it, and let's move on to the next problem. So the same code can be used to solve the first problem also. So the last problem is minimum operations to make elements with k subarrays equal. So it was a pretty good question, and it is kind of similar question to this, which has also came in a Leetcode Weekly contest. And my idea or approach behind solving this problem was almost the same to this, where we maintain two sets or maps based on some conditions. So you can also check out the same video or the solution for this and how we got the idea of solving this problem. So I'll link down the video in the description. So let's see, continue with our current problem, that you are given an integer array nums and two integer x and k. So let's quickly write down the same. So we have, this is our question 4. So we have array nums and two integers x and k. So you can perform the following operation any number of times including 0. So in the operation what we can do is increase or decrease any element of nums by 1. Cool. So we have to return the minimum number of operations needed to have at least k non-overlapping subarrays of size exactly x in nums where elements with each subarray are equal. So what does the question says? So let's say you have a array which have some elements 1 2 3 4 5 6 and 7. So I also have x and k with me. So let's say my x is 3, k is 2. So I have to return the minimum cost to make k non overlapping subarray of size x with equal elements, and in one operation I can increment or decrement any number. Cool. So or minimum cost, or I can say minimum operations. So let's say we have this subarray and this is of size x, which is 3, and if we try to make the same number of the number of elements, or sorry, the all the elements same. So let's say we are updating 1, 2 is same, decrement 2 sorry 3 to 2. So the total number of operations required to do this is 2. Similarly for the subarray 5 6 7, my let's increment 5, make it 6, keep 6 as it is, decrement 7 to 6. So the operation for this will also be 2. So we had made two non-overlapping subarrays of size 3, and the cost of doing this is 4, which is the minimal, and we cannot go more lesser than this. So we have to give the cost to achieve the same thing. So before proceeding with the question, let's discuss a very simple thing which can be easily solved with mathematics. So let's suppose you have 3 or let's say 5 numbers, and you have to make them equal with same operation, that either increment any number or decrement our number. ठीक है. So what is minimum cost to do so? Let's say you have some numbers 5, 7, 8 or 1 and 3. These are the 5 numbers. What is the minimum cost to make them equal? So either you make all of them equal to 5, all of them equal to 7, all of them equal to 8, all of them equal to 1, all of them equal to 3. So how can you say that yes, this will be the minimum cost to achieve the same thing? Either you start making every number equal to any selected number and check for every possibility and get the minimum out of it. That would be the most stupidest thing to do during the contest. Second thing is, when we just look on them all together, we can see that y 1 3, let's write them in the sorted or 5 7 8. So if we see the difference between the minimum and the maximum element, we can easily see that if we start making the minimum element to the maximum or maximum to the minimum, that would gonna cost me a much, and I don't want to get a maximum cost. I am looking for the minimum cost to do this thing. So the best thing is to shift all of these elements towards the middle and shift all of these elements towards the middle. That would be the most optimal way to make them equal. So what I'll do is make 1 equal to 5 by doing 4 operations on it, make 3 equal to 5 by doing 2 operations on it, 5 doesn't need any operation, 7 needs 2 operations, and 8 needs 3 operations. So the total would be 3 plus 5, 8 operations. So by doing 8 operations, I would be easily able to make them. But instead, if I had made 1 equal to 8, that would have cost me 7 operations for one element only, and there are more elements in the array. So the ideal way is to make everything equal to the middle. And how can we get this middle element? This is nothing but sort the array and get median. Cool. So that's how you can achieve this thing. And then we just have to take the absolute difference between median and every element. So can we just use the same idea in this question? Let's see what we need to do. We have to we have a array and we want subarrays of size x with same equal elements, and the operations are same that we just discussed. So to make 1 2 3 equal, we had shifted all of them towards 2. To make 5 6 7 equal, we had made all of them to 6. Let's see some other cases in the question also. So for this subarray, use the operations to add 3 rows of 1. So finally they are making of 3 sizes. So minus 2 1 and 3. Cool. So they are trying to make minus 2 comma 1 comma 3 equal. Cool. So they are sorted in some order. What will be the median of this? 1. If this is the median, what are the number of operations needed to shift minus 2 towards 1? 1 will be from minus 2 to 1, 1 from 0 0 to 1, which is the absolute difference between them. 3. Absolute difference between 1 and median, 0. Absolute difference between 3 and 1, 2. So the total number of operations needed is 5. So they had told that use 3 operations on this and 2 operations on this. So by doing 5 operations, you will be able to achieve this thing, which will be giving you a subarray of size 3 with equal numbers. So even after looking at the examples, you will be able to come up to this, that yes, making all the elements of any subarray equal to the median of them will be the best thing. But the another constraint is you have to sort the array and get the median. So sorting all the subarrays and trying all the possibilities will gonna give you TLE. So we'll see how can we achieve the same thing in lesser amount of time. So there is a question on Leetcode itself, which is running median, I guess. Find median of a data stream. Yes. So this is the question. It can be found on Leetcode or any other platform, and there is a similar question in CACS problem set also, where you have given a array, and for every subarray of size k, you have to find the middle element of that also. So this is the main idea behind solving this problem. And if you want a optimized version of how to do this thing, so there is ordered set in C++, or there is balanced sets approach. So this is a data structure which can help you do the same thing very easily, or this is implementation of data structure by yourself that will help you to get the same thing. Cool. So we'll discuss this. Second thing is we have to solve the question, which is make k non-overlapping subarray of size x with equal elements that will cost us the minimum amount. So for a array, there can be multiple elements, right? We don't know which subarray has to be chosen. If size is 2, so we can choose any of these subarrays and in any order, but they should not be overlapping. That was the only condition. So if I number the subarrays as 1, 2, 3, 4 and 5, so there can be many on let's say my x is 2, k is 2, so there can be many possibilities, selecting 1 and 3 together, selecting 1 and 4 together, selecting 1 and 5 together, and I don't know from which subarray I'm gonna get the minimum cost, right? So just by thinking of this, you will be easily able to get that you have to try all the possibilities that are present. So you have to go with dynamic programming. Simple. You have to check all possibilities. So quickly shift towards dynamic programming. So here we can have a very clear and clever state that dp of I comma k as minimum cost to make k non overlapping subarray equal of size x from or not from up till ith index. Cool. So how can we transition on this particular state? If I say that you can easily get the cost, let's say you have a function f which will return you cost of subarray, then your transition would be very easy. If you are standing at any ith index, and how much size of subarray do you want of x? So I minus x would be the starting point of your subarray, I would be the ending point of your subarray. So if you have the cost of this subarray, then your state would be, if your dp of ik is equal to minimum of itself, comma, dp of I minus x minus 1, because I minus x is the starting point, and from this point I minus x minus 1 you want the answer. And if you had found a subarray, so you can decrement the count of it, which is now you want only k minus 1 subarray plus the cost of it. Cool. So this will be the transition to iterate on it. And how are we going to calculate this cost? That is the secondary thing, but this will be the simple transition to get the answer. And our final answer should look like, it should be dp of n, or k, yeah, or if we are talking about indexes, it should be n minus 1, and up till ith element, then it should be dp of nk. So that's up to you. So that could be a possible solution. And let's discuss the time complexity first. Up till here, so we are iterating on n k times, so the time complexity is simply n into k, and to compute our state we are just taking order of 1 time. How? We don't know how are we getting this cost, just assume that we have a function which will return us the cost. So the transition time is order of 1, or let's say, let's define it as not order of 1 exactly, let's make the transition time as order of x, not x, x is a very order of t here. Cool. So this is the time complexity multiplied by order of t, which is the transition time for the state. How much order of time can we afford? Let's see this. So if we look at the constraints, my n can go up to 10 to the power 5 and my k is 15. So my n is 10 to the power 5 and this is 15. So this is almost negligible and 10 to the power 5. Cool. So how much order of time factor I can have in my affordance, that this should not give TLE. So at worst this t can be equal to in worst case my x can be equal to n, which means I can have the whole sub array at once. So to sort it and get, if we do the trivial way, sorting will gonna cost me n log n time more. So if we multiply 10 to the power 5 into n log n, that's gonna give us TLE. So we cannot just go with the brute way to sort the array and then get the median out of it and then calculate the whole thing. So this is gonna give us TLE. So how we gonna calculate cost? How to calculate the cost in less than n log n, or we can not even go n. So we should be in a time constraint lesser than n log n or n. So the only thing left is we can have at most log n time taken to get the cost. The second thing is, we had already discussed that we need the median of the array so that we can calculate the cost. So here we had just seen that we have to check for every sub array. So once we had checked for this sub array, I'll move to the next sub array. While moving to the next sub array, what change is happening? I just need to focus on that. So for any array, if let's suppose this was my previous subarray that I just checked and updated my seeds based on that. Now I will be moving from this point to this point, making this subarray. So change was this element is added, this element is removed from my scope. Rest of the things are same, right? Just looking at this, we can easily see that this is a sliding window, and at every point of time I will add one element and remove one element from my scope. So what is my scope? I need to calculate the cost of this window. So we need to calculate the cost of this window. So what does this cost tells? Cost should be the sum of absolute difference between what I can say, between every element and median. Correct? This is the cost. So if we can see, let's suppose I have the sum of this subarray. Okay, let's not erase it. So if this is subarray 1, this is subarray 2. So for subarray 1, what things just change? So I already have sum of. So first let's get into the maths and deduce a relation that how this sum of absolute difference of all of these values and median is gonna work. So let's say there are three elements a1, b1, sorry, a not a1, a, b and c. Cool. So my cost will be, let's say m is the median between them. So my cost will be m, or absolute difference. So let's not get into this. So a minus m, b minus m plus c minus m. In some of the cases, c would be greater than m or c would be less than m. We don't know. So overall, if I sum all of these things, it will be nothing but sum of array, or if I take m together at single side, it will be, just a second, yes, so it will be a plus b plus c minus 3m. So this is nothing but this is the sum of, let's move this a little bit up. So this is the sum of array minus this is what, size of array, multiplied by median. So for getting the cost of any subarray, we had deduced a relation that it is nothing but the sum of array subtracted by size of array multiplied by median. Cool. How this thing is gonna change when the subarray is shifting? So first thing that is gonna change is sum of element, in which one element is added, one element is removed. On the basis of that, the sorting order changes. So there can be a possibility that there is a change in median also. Median might change while adding and removing the elements. So let's say we have a window over a array which is from this to this point. We already have some of this. We already have median. How did we got the median? To get the median, I have a sorted list. This is my sorted list in which all the elements are present in sorted order. I know middle of this is median. Once I have to move further, what I'll do, I'll remove this element. Let's name it as x. So while moving, what I will do, remove x. So remove x means decrementing my sum and removing x from here also. After that, if the next element is y, so I'll add y to it, and then I will put y in my set. My median might change, and then I can easily return my cost as sum into size sum minus size into m, which we had just discussed about. So this will be the transition while moving or sliding the subarray over the whole array. So this updating the elements in the sorted list and getting the median part can be easily done with ordered set that is present in CPP, and it will work in log n time. That is for sure. So our idea is pretty much clear. We don't have to do anything, just update our sums, update our median, and change elements based on the sliding of the window, and you are good to go. So this is one way of doing this by using ordered set. Second way is to maintain the sorted list. What we can do is we can maintain two sets. There is I guess similar thing in heap also, that you can maintain two heaps and two sets. Both of the things are working in the same way. So we can maintain two sets. How two sets? So basically, if this is my sorted list, so what is the issue in maintaining a single set? If I have a set, I know I have all the values in sorted order. Cool. But to get the middle value, I have to iterate on set, because I cannot just use indexing on set to get the middle value, and that is gonna cost me more time that I cannot afford, because sets already work in log and time for sorting. So I cannot waste my time on iterating, because I almost have a buffer of log and time that we just discussed here, that we should calculate the cost in log and time only. So we can use the sorted order property, but instead of iterating on set, what we can do is इसको दो पार्ट में ब्रेक करते हैं, which is half elements in the one set, which is set 1, and half element in the second set, which is set 2. So once we do this, we already know that, and we will follow a rule that at any point of time, the difference between size of set 1 and set 2 is at max 1. So by following this property, it will help us maintain two sets, both in a sorted order, and our median will only be present at either the end of it or the top of it. How? Let's see. If there are, let's say, total 4 elements, which is 1, 3, 8, minus 10. Cool. We don't know the median of them yet. So let's divide them into two sets. we encountered 1, we had put 1 here, let's say. We had encountered 3, we had put 3 here. But at this position, the difference between their sizes is 2, which is not achievable. So we'll move the smallest element from to the upper set. Now both of them have the same size. Cool. So now we encounter 8. We'll put 8 here. The difference between their sizes 1 only. Where is the median present? At the top of it. Whichever has the greater size will have the median in it. So now we have minus 10. Let's put minus 10 here. So it will be here. So now the difference is greater than 1. So we'll take out minus 10 from here. We'll put minus 10 and it will be at the top of it. So now both of them will have the same amount of elements. So median can be this or this. Both of them are fine to us. Cool. So that's how we can use two sets and we can rebalance them while adding or removing an element. So adding or removing any element costs us log n time. So let's write it down here. So how much time complexity will it gonna consume? So if we add or remove any element, that will gonna cost us log of n. After that, if we have to rebalance at any point of time, the max difference between their size is 1. So we have to shift one element. So to shift one element will get log n time. So this is nothing while consuming or rebalancing them, and at any point of time we can get the middle element of sorted range. So once we have the middle element, this is nothing but our medium. Cool. So we can achieve this property to query and get the cost of every subarray, and while shifting our element or while shifting our subarray to the next point, what we'll do, we'll remove x, we'll put y, we'll compute the cost again. Cool. So once we are maintaining these things, we can, there are many different ways of doing this, there are many syntactical different ways of achieving this. So I'm not getting into this because people use different ways of doing this. So this was the generic idea behind how to use this and how to maintain these two sorted or balanced maps. So my approach for this problem was this, that I will be using a state dp of I comma k, which we had just discussed. While updating I to I plus 1, I'll add this and remove old element. For this I am using that two balance sets, and my balance sets are storing arranged in two parts. So I was maintaining two sums, which is sum 1 for this, sum 2 for this. So to get the maximum element at the top of the to get the maximum element at the top, because while rebalancing, if we have to move any element from this to this, what I need to do, I need to shift the minimum element towards there. I need to shift the minimum element so I can get it at the top. But from to get any element back to the set 2, I need the max element. So to get max element easily, what I did was, while putting anything into set 1, multiply it by -1. Why? Because if there are different elements, let's say 1, 2 and 3, so to get 3 at the top, what I did was multiply every element with -1. It will make it as -1, -2 and -3 is the minimum, so it will be at the top. So while putting this, we'll do the same. While taking out, just do the same process. So elements inside the set 1 will be stored like this, but actually they are this. Cool. So that's how I'm gonna do this, and sum 1 and sum 2 will give me the sum of both the sets. So at any point of time, how I'm gonna calculate my cost? So cost was actually sum of all elements minus multiplied by the size into the median. So easily I can get median. So if my size of set 1 is greater than the size of set 2, so element it is at the top, so set 1 begin and it should be multiplied by -1, else it is in set 2, can be achieved in the same way. And once we are good with the median, the cost will be, let's compute the cost of both of them separately. So cost of set 1 is nothing but the middle element will be greater than the median element will be greater than all the elements in this, because they are the smaller elements in sum 1. So my m is median. So size of this is not set 1, actually it is actually the size of set 1 minus the sum 1. Cool. Plus for the set 2, the median element is the least element, so in that case the sum 2 is greater and median element is less than that. So this is the way we can get the cost. So it can be reduced to this, which is m multiplied by size of set 1 minus size of set 2 minus sum 1 plus sum 2. So at any point of time while shifting my subarray, I can update the addition and removal of the element and get the updated cost in log n time. So the total time complexity will be order of n into k multiplied by log of x, I could say, because I will be maintaining a window of size x, and this x can be an inverse case, but in best case it will be log of x, because x can be 1 also. So this is how I'm gonna do this. So let's see, and the space complexity will be n into k into x, because this is for maintaining a DP array and this is for maintaining two sets. The two sets will both store at most x elements at a time, so this will be the space and time complexities for it. So let's see the code for this, and this template can be used and at many different solutions, which I just showed you the previous the problem starting before starting this question. That problem can also be solved with the same concept. So let's quickly start with the addition function. How are we gonna add to the set? So if my set 1 is empty, I will insert the element in, so here I had made two variables, sum 1 and sum 2, initialized to 0, and these are my two multi-sets. Why multi-sets? Because there can be a same element in the array and we have to remove or erase only the single occurrence of it. So that's why move to multi-set, otherwise set is a very good approach. So for adding, if my size set 1 is empty, so in that case I will insert into set 2 and will add into sum 2, the same element that I am adding, x. Otherwise, if my set 1 is not empty, it means both of the set 1 and set 2 have some elements, then I'll compare with the previous median, I would say, that whether my current element is greater than that, then I will put it into set 2, otherwise I'll put into set 1. And once both of this thing is done, I'll update and check whether my sets are balanced or not. Let's see what these update and check functions are doing. Update function checks whether my size of set 1 and minus size of set 2, which is if my size or if my set 1 is greater in size, then the rebalancing happens here. And I'll fetch element from the beginning of the array, and in add function also, let me clear this, that while putting the element into set 1, I am putting the negative of x. Why negative of x? To make it function as the max heap, you can say, or to get the maximum element at the beginning of the set. And someone is working simply with adding the x. So in this update function, if they have difference in their size, I'll get one element from the top of the set 1, will multiply it by -1 to make it normal, then push it into the set 2, update my sum 1 and sum 2 by incrementing and decrementing respectively from them, and then I'll erase the element from this set. So the purpose of using multi-set is this, that in this case only the single element will be removed, and if the same element has multiple occurrences, it won't be affected. Once this update is done, I'll do a check whether there can be a possibility that my set 2 has grown into size. So at that time, if this is happens, I'll get the element of top of it and will move to the set 1, and the same process which is in the update 1, and this is in the reverse order. So here also, while putting into set 1, I am putting the negative of that element. So these are the update and check functions. This is the remove function, which works similarly like the add, that if my set 2 has the element, because I am maintaining the sets in a way that even at any point of time, my set 2 can have a more number of elements as compared to set 1. So first we'll check in set 2. If it is not in set 2, then I'll check it in set 1, and it will be definitely in set 1 because either of the sets will contain the element. So if it's there, we'll remove the element from my sum and will erase from the set also. So else it will be in set 2, so we'll update from there, and once the element is erased, we'll do the update and check part. So once this thing is done, I'll start constructing my DP. So initially for no elements and for getting 0 subarrays, my answer is 0. And this is the update key part. Let's not get into this first. So here I started iterating on number of elements. So number of elements can be from 1 to n plus 1. So initially I'll copying the state, because okay, so we had discussed it somewhere here. Yes. So this is just for the single state, but for my DP of I. So let's do this here only. So if I had computed answer up till here with all the subarrays, it will be similar, that if there are two possibilities, that either choose this element into a part of subarrays or skip it. So if I want to skip this part, I can easily say that my DP of I is equal to my DP of I minus 1 for all states, and I'm going to skip this and I can move further. And while choosing this, we can add it to my window and remove old element. So while adding it into the window. We'll just call the add function with this element, and the previous index would be I minus x, and if the I minus x minus 0th element minus 1th element is not in my scope, we'll just stop, and if it's in the scope, we'll remove it from the uh, window. And if my index is negative, so we cannot do anything, just continue for that, because initially we are not filling the sliding window of size k, so these conditions are for that part only. So initially we are just adding elements until the size of x is maintained. Once it is maintained, we'll start removing the elements also. So these are the sizes of two sets. So we are getting our median from, if size of set 1 is greater, median will be at that set, and we'll just take neglect minus of that, and otherwise my median would be in set 2. So this is how I'll get my median, and after getting my median, I'll update all the states, which is nothing but for every dp of I comma k, I'll update it with dp of, or you can say the transition that we just wrote above, this thing, dp of I minus x minus 1 with k minus 1 and the cost. So in this update k function, we are just iterating on every possible k, and if my I minus x j is already less than 0, which is, we had initialized this with minus 1, so this state is not computed. So we know that we cannot take consideration of this particular subarray, and if it is computed, then we know, if my current state is not computed, just put the value directly over, and this is basically the cost that we just discussed at last, that it will be here, median into size of set 1 minus size of set 2 sum 1 and sum 2, median into size of set 1 set 2 sum 1 plus sub 2. So this is how I'll just update my current state, and if it's already computed, I'll just update it with the minimum possible option. So once this update is done, I'm good to go. So after computing all the dp and comma k states, my answer lies here on dp and comma k. So this was the solution for this problem. I know it is a bit lengthy, and it almost took me around 40-45 minutes to just implement this thing, because even I know that how I'm gonna get this subarray or the median part of it, but implementing it is a hefty job, and these kind of questions may get or may look very difficult, but even if you know the approach of this, then it would be more easier for you to implement or manipulate it around. So thank you so much for joining, and I hope you understood the problems and the solution.